Hello everyone and welcome back to our Over the Wire series. Today we're going to be taking a look at Natas 13. It's just a couple housekeeping things. I already have our get flag from last time. I just have this open so I can get the build output so I can grab that password. As well, I have our proxy running in the browser with Burp Suite ready to go. I don't have intercept on yet, but I just have it running. All our requests are sort of being routed through that proxy, which you can see I'm just using the Foxy proxy extension here and paste in that password. And you can see we're authenticated and we have a web page that looks a lot like the last one. However, for security reasons, they are only accepting image files. So that's interesting. It looks like there's some sort of filter in place. I guess there are a couple of different ways you can sort of do this. I don't know if they're looking at the extension, like the file extension, or if they're looking at, some other makeup of the file to determine what kind of file it is. It looks like it needs to be a JPEG. So let's just browse and try our nothing.jpg from last time just to make sure that this is going to work. You can see it looks like that worked, and it was sort of like the last level, put into this upload directory with a random file name. So let's look at the source code to see sort of what's going on here. So you can see it kind of looks like the last level a bit. We have some of these same functions here to generate the random string, make the random path, for example. But you can see it's got to be here somewhere. This must be it here. So you can see we have some nested if-else statements here, again, to make sure the file size is correct or not over that, 1 kilobyte range. But you can see here, this one, exif image type, it's using some sort of function here. It looks like to be a built-in function with PHP to look at the uploaded file and basically ensure that it's an image. So let's take a look at how it's sort of doing that. Maybe if we just look up this exif image type function in PHP. You can see this first result here, the old handy php.net manual. So you can see it looks like this exif underscore image type function or method takes in a file name and basically determines the type of image that it is. Ooh, and you can see here, very interesting. So it reads the first bytes of an image to check its signature. And this sort of deals with magic numbers or magic bits or magic hex codes, whatever you want to call it. If we just look at, let's look up a JPEG image, for example. So you can see under this Wikipedia page here for JPEG images, there's this magic number value here. And you can see it's set to FFD8FF. That's sort of a hex code. Basically, these are stored inside the file itself. Typically at the start of a file, and it's sort of like a sequence or a string that sort of identifies what type of file you're dealing with. So you can see in this example here for GIF or GIF images, they always begin with an ASCII representation of GIFs 87A or GIF 89A, and that basically tells programs and systems and applications what sort of file you're dealing with. You see for HTML, for example, you get the opening HTML tag. PHP obviously has its own opening PHP tag. So there are a bunch of different ways that you can sort of represent this magic number or magic, code. Sometimes it's in the actual markup, like with HTML, for example, or sometimes it's a hex representation. And in the case of the JPEG image, you can see that it was. So let's sort of take a look at this further, and maybe if we can manipulate this, because we can change sort of these values in our file. So maybe if we can manipulate that to make it look like a JPEG image, it'll upload with no problem. Because that appears to be the only, sanitization or filtering or checking that I see going on here. It's basically just running this command to see what type of image file it is. And if it's not an image file, we're going to get files not an image. So yeah, let's make a PHP payload, kind of similar to last time, and then we'll try to upload it, see what happens, and we'll start tinkering to sort of figure out a way to get it uploaded. So let's create our PHP file. So we can just use VI for this. Let's call it getflag.php. Or, whatever you want to call it, exploit or payload. And we'll just do a one-liner here. So we'll enclose this with the opening and closing PHP tags, and we'll run the pass-through command, which we've been doing to sort of take advantage and run commands, any command we want on the local web server. And what we'll do in the parentheses here, we will specify which command we want to run, and that's going to be cat, because we want to cat out the etc natas underscore webpass, read the password for natas 14. Okay, so that looks good to me. Let's save and close that. And just to demonstrate, how these magic codes or magic numbers work, if we run the file command on our getflag.php script, you can see it's in ASCII text, but more importantly, it is a PHP script sort of identified by, that opening and closing PHP markup here. And maybe if we're sort of able to inject that magic number for a JPEG image in front of this markup here, we might be able to trick these systems into thinking that it's actually a image file. So let's go back here, and what I will do is turn on our interceptor, and then we're just going to browse for that file. So we'll just try to upload this and we'll hit upload file. And we should see Burp Suite catch that request there. So you can see, similar to last time, we are uploading this file here. You can see the actual file that we're uploading here. You can see the content type is in application x-php. We have our file name here. Let's just send this to repeater so we can, mess with this later. And we can just forward off this request and see what happens. And you can see we're getting that file is not an image. And again, typically this could be because of the file extension, or in this case, the magic number, because we looked at the source code and we actually know what's sort of going on if we're doing some, white box testing here. So clearly that's not going to work. We're going to have to figure out how to inject this magic number. So just in the repeater tab, just to demonstrate, I think our only option here is going to be to deal with those magic numbers, because even if we change the content type here to image/JPEG, which is, the content type for a JPEG image, and if we try to send that, I'm pretty sure we're going to get the same result. Yeah, and you can see file is not an image. So let's go the magic number route. Well, there are a bunch of different tools we can use to do that, but I think one that's built into Kali Linux is called hexedit. So I'm going to run that on our getflag file here. Hexeditor is the one that's pre-installed, so let's just run that again on our PHP file. You can see I'm using a terrible looking shell here. Let me try to change this. Still pretty bad, but doable, I guess. Let me zoom back in. So you can see we have our sort of hex representation of our file here on the left, and you can see the actual ASCII makeup or contents of our file on the right here. And so again, you can see we're starting out with these hex values here. If we go back to, maybe I closed it. If we go back, actually, I think this is a good repository we can look at for magic numbers. And you can see here under JPEG, you can see we have the hex digits here. So it's going to be FFD8, FFE0. So we can take that and basically just overwrite these first values here to sort of inject that into our file. So it looks like from a high level that this is actually a JPEG image. So let's try to do that. All you need to do really is just start typing. So we're just going to do FF here, D8, FF again, and E0. So you can see all the changes we made are in green here. And if we look at the actual ASCII text of our file, you can see we sort of accidentally overwritten our opening PHP tag here. So if we save this, we're actually going to break our code because that's not valid. We need to have that opening PHP tag there to specify once this is executed on a web server, for example, that this should be run as a PHP script. So what we need to do kind of is to add some bytes at the beginning of the file, just so we have some room to play with, and we have some room to overwrite this without actually overwriting our payload. So let's just do Control-C to exit this without saving, hit yes. And let's just add some white space to the beginning of our file here. I'm just going to add a couple of lines here. I think that should be sufficient. And then we'll just hit save, and we'll go back to our hex editor. As you can see, this first bit of hex here is just 0A, 0A, 0A. That's sort of this white space that we created, and we're fine to sort of overwrite this at this point. So let's go back and basically just input our hex data once again. So that's going to be FFD8, FFE0. And you can see, it looks like that was perfect because we've sort of overwritten this white space here, and then we have our opening PHP tag, so that's not going to get cut off or overwritten, and this should run fine once it's sort of executed on a web server. So that looks good to me. Let's just do Control-X to exit and save. So now let's run file again on that PHP file. And you can see, even though we have a .php extension here, when we run file, it's reading this as a JPEG image. And why is that? Well, we have this hex representation of, the JPEG magic number, which sort of doesn't really show up properly when you cat out the file, for example. But that's fine. That shouldn't break anything. So perfect. That should be fine. We should just be able to upload this now. I'm going to browse for our getflag.php, which is actually secretly a JPEG, secretly a PHP file. And let's just hit upload. And perfect, that seemed to have uploaded with no issue. And if we just go to, well, this URL here, we should, but it doesn't look like anything's happening here. Rather, we're getting an error message. Apparently there were some errors on this file. And if you think about why this might be happening, well, it's uploaded as a JPEG image. You can see the .jpeg extension there. The magic number sort of sees it as a JPEG image, so that checks out. But then when the web server tries to serve or display the image file, well, it's not actually an image file. And it's not sort of encoded or, the syntax is not in an expected way of an image file. So it's causing errors. So we need to actually change this, kind of like we did in the previous level, to be uploaded as a .php extension. And the way we can do that is by sort of editing the request inline, because if you remember, there's a hidden input here on the client side for file name, and it sort of has that .jpeg extension hard coded in to whatever we upload. And that's vulnerable because this is on the client side. We can edit it. We can even edit it on the web page itself. But just to sort of showcase that, I think this should work fine if we just sort of manipulate this on the web page. And how do we do that? Well, let's open the dev tools here. Let me see if I can make this wider. Awesome. And now let's open up the content here. So you can see we're actually looking at the HTML markup of the web page here. This is the DOM, or the document object model, which is sort of a representation of what we're seeing on the page in markup form. Now, if we open up this form element, we should see, we have these hidden form values, one for the max file size and one for the file name. You can see the random string that's been generated and the hard-coded .jpeg. Well, we can just sort of double click and change this to .php. So whatever we upload is going to be sort of uploaded onto the web server as this file name under the upload directory. So it's really that easy. We don't even need to capture the request because, again, this is on the client side. We can just change this value for a particular upload. And then let's just browse for our file again and just hit upload. And just like that, you can see we are getting our uploaded file with the .php extension. So let's see if this will work. Open that up. And yeah, there we go. You can see we're getting the password aside from our magic number here, which is fine. No big deal. We can just copy our password here, but we are getting remote code execution on the server. We can run any command we want. All we had to do really was just change the way the application sort of perceives our file that we're uploading and make it think that it's an image file. There was no filter on what file type we needed to upload, which again can be bypassed, and maybe there's a further level in this series that will cover that. But no, all we needed to do is just change that magic number there at the start, and we are getting remote code execution. Perfect. All right, so let's script this out again with our getflag script. I'm just going to copy our script from last time into our directory here, and then I'm just going to open it with Sublime Text. I'm just going to update the authentication here for Natas 13. And let's think about what else we need to change here. So I'm just going to comment out our second request that we're making here. If you remember, we're opening a session, we're uploading the file, we're extracting the file name that we uploaded, and then we're making a GET request to sort of extract out that password. But let's just see how our upload is doing here. So let's just print out response.text and try that. Okay, so that worked right away because if you remember, we didn't really change the name of our file that we're uploading. It's still getflag.php, even though it's in this different directory now. So you can see we have getflag.php here. So it's just going to point to that file because we're just opening it in this sort of relative directory here. So let's uncomment this. Then I just want to print out dir just to make sure we're getting the right output here. Yep, perfect. You can see we're getting the file name. Just sort of walking through our code to make sure everything's working. Oh yeah, I remember watching back. I don't know why I sort of copy and pasted this again. We already saved that as URL, so we can just sort of append URL to dir. And just to be extremely thorough, let's just print this out. Yep, perfect. So we're getting, the URL here with the upload directory appended with our PHP file. And all we need to do is sort of make that GET request to this URL and then print out the response there. Perfect. Yeah, there it is. You can see we're sort of getting the malformed hex data as encoded in ASCII here, and it's obviously not showing up well. And we just need to sort of extract this out now just to get the password nice and clean. I'll just get rid of these comments first. We should just be able to do this quite cleanly and easily with Python string slicing. So you can see we're just getting sort of 4 characters outputted here because it's, again, that hex code encoded into ASCII, but it doesn't really work as ASCII, so we're getting these question mark characters here. But there's just 4 of them, so we should be able to just run a string slice, and we can sort of do that with the square brackets here. And we're just going to do 4 and then colon because we want to sort of cut out the first 4 characters. Let's try that. Perfect, yeah, so we're getting the password. We've cut out those first 4 malformed characters, and just like that, our getflag script is done, and this level's done. That wasn't too bad. Let's test it out. Just going to run our getflag.py, make sure it works. Perfect. Then we're going to send that out to Natas 13. And then run natas sh for natas 14. Excellent, we are in, and the next level again has a form, this time with the username and password, so we will tackle that in the next video, so stay tuned. But for now, thank you for watching this one, where we sort of explored magic numbers, where we exploited the web server with another file upload vulnerability in order to get remote code execution. So thanks again, and take care.